Greetings, Codeland! Hello and welcome to my presentation. Thank you so much for coming. My name is Nick. I am a software engineer. I do DevOps and infrastructure building type work, and this is a story about Docker. This is a story about Docker, and we are going to tell it by building a simple app from a Docker file on our local machine. And it's a story we don't always think about, but it's one that's important to know because Docker is a lot more than a container. There's a few other characters to this process. One very important character is our whale. This is the Docker daemon that exists on your machine. There's also the computer, which is the ocean in this context. That is the whole environment we get to work with. Finally, we have the container, which is the end goal here. But as I mentioned and alluded to, there's a lot of other steps before we get to the container, and we're going to look at those in a little more depth. The first step before we even think about containers is thinking about how to get to the Docker daemon, and that is a process that interacts with your computer. So in this example here, I have my terminal opened on the left, and I have a oceanic representation of my computer on the right. Right here is every place, every type of file that exists. It's my full file system. And the things I have over on the left is representative of what is going on in the right. So if I, for example, list all my files, I have some pretty standard files for a node type application. We see this expand over here. It's all under my code directory. And I have a Docker file, so the natural thing to do, of course, is going to be building this Docker file. So I use a well-known build command, I give it a tag argument, and I add a dot. Now listen, this dot here is really important. It's small, but it's not to be underestimated. This dot represents the build context. We don't hear about the build context too much, but it does mention it in our terminal when we type Docker build. It says here sending build context to the Docker daemon. This is what the Docker daemon is going to see. What do I mean by see? Well, our trusty whale here, he only floats above the ocean. He never dives into it. In other words, this becomes our build context, and our Docker daemon here doesn't see anything in our computer. According to the daemon, its file system is a blank slate. You can think of it as a USB drive with nothing in it. It is this command that is going to send some files. In this case, we have specified this dot here, which means our current working directory. That is under users nick code. So everything highlighted here is under code in our directory. It is this section of files that gets sent to our daemon, and this is what the Docker daemon sees. Why does this matter? Well, everything we have in our Docker file later on is going to be pulling from not our computer, as is sometimes assumed, but from our Docker daemon and this build context we have set for it. Some things can go wrong here. Whereas if I'm in my computer, I can specify this special two dots, which means a directory above the one I'm in. That means I could just copy something that's maybe in the nick directory. If I had this same type of strategy that I used in a Docker file, this would be a little more, wrong, because this same command would give us some sort of failure in the Docker build process. There is no context above the context we already have. Here, we already have this root that we've started at, root and our build context underneath. There's no higher level to go above. We're dealing with a much smaller subset. The other important thing to realize is that sometimes you don't have all the files you want in your build context, but other times you have too many. Now, node modules contains a bunch of other dependencies in it, a bunch of other files that gets generated from an npm install, basically a run command. These things can happen later on in the process, as we'll see, and copying them at this point is a bit redundant. Not to mention, it assumes that you've built in a different architecture or a different operating system outside of the container you're going to be working with. In this case, I have replaced node modules with those we would get installed from Create React App. And if you didn't know this, there is a lot of node modules in Create React App. When I ran this in my own computer, it took about 4 or 5 minutes. The actual metrics was that our build context was 171 megabytes. This can be kind of unsavory because when we build our container, this copying to a build context happens every time. So if this is taking 5 minutes for me the first time I run this, it's going to take at least 5 minutes the second time I run, and on and on and on. So it's important to keep our build context as small as possible. Now in this case, we do not want to actually bring node modules into our Docker context. Not yet. So the way we would address this is with a Docker ignore. Very similar to a git ignore, Docker ignore follows the very same structure where you can specify files. You can also specify paths as well. A lot of other stars are also supported. But you specify your different file types, and these are the things that get ignored. Specifically, they will not be sent to the build context at all. If I were to add this newly incorporated Docker ignore file and hit the same command, what's that going to do is it's going to block out extra things we don't need and instead copy everything else. So now I only have a much smaller bundle, essentially, that I've sent to the Docker daemon. The feedback tells me the same thing as well. It's now saying that this is less than a megabyte, and that is a huge difference from when we had the gigantic node modules that we were copying into our build context. This is going to save us tons of time over the long run, and it's a great idea. It's a great concept to think about when you're setting up Docker ignores and specifying a build context. Now, we've gotten everything to our Docker daemon, but where we are going is different still. At this point, once the context is set, we only have our build context that we're working with. Yeah, the ocean's there, and it's underneath it, beneath the surface, but it's really all about our Docker daemon now and the container that it is building. This from command basically is saying, give me a different operating system. It's a little more complicated than that, but for this purpose, we can say, give me an operating system, such as a Linux operating system. This right here will look very familiar to anyone who's looked in the root directory of a Mac OS or a Linux computer. It has a bunch of different system important files in it. But for building an application, this is not really areas that we want to put code to. We want to put code into its own isolated spot, and that's where our first command in our Docker file comes into play. This work directory here will create this file, this code directory, and it's going to make it a default spot for all other subsequent commands, at least most of them, which we'll see in a minute. So now that we have this special code directory set, we can start copying files. Copy is the main go-between that will transfer files from the Docker daemon into our container. Kind of the same way that that build command, that first build terminal command, moved files from our computer to the daemon. Now we're going one step further. The first argument is for the build context, which is over here, and the second is for our container. Notice that I have a relative directory for the site. That dot again represents the current working directory. But what is the current working directory now? It is the work dir that I've set up here. Remember, I mentioned that was pretty important. This whole thing is going to resolve to code/site. In other words, we will put site within our working directory. I want to do another copy command, and this time I'm copying a file. But I get this kind of strange error back. This error looks kind of scary. It's actually so large that I had to truncate it a bit with these 3 dots. But I just want to be here to tell you that it's okay, and it's actually a very simple error. Whenever we see some sort of like copy failed, something like that, and we see this long string of commands followed by this Docker builder type thing, we just want to look at all the files that are after that slash. This, again, is the build context. And under the scenes, behind the scenes, this is actually where the build context is being stored. So we don't really have to pay attention to anything here. We just need to pay attention to the stuff that starts looking familiar to us and realize that this config.json is not in our build context. And if we look, we can see it really isn't. We have docker ignore, docker file, package.json, package lock, site. We don't have config.json. So this is an invalid command. It's a mistake on our end because we never had this file to begin with. And we don't need it, but I wanted you to know that error and realize that that error is actually pretty easy. And it just means a copy command doesn't have the right file for the most part. Another important command, of course, is run. This is going to be how we are getting those build modules into our container. Rather than copying them in a very slow way, we're going to run the native npm install within our Linux container. And this is what's going to make things work. Or at least it should. We're running this in our code directory. It looks kind of like this if we did it on a command line. Again, that code is in this container. But something's going to happen. That's the error there. We get a npm-like error. This is a runtime error, and this is saying that there is no file or directory in code/package.json. This is all happening within our container, not the Docker, not the build context, and not our computer either. And this is saying that we have no package.json within our code, and it's true, we don't. We only have site. We might have package.json in our Docker daemon, but we don't have it in our container. So we also need to copy that as well. We can take this struck out command and replace it with something a little more useful. We do have a package.json in our Docker daemon, and now we have it added to our container. Our npm install will now work, which will add the node modules in a much easier way that can support caching later on, and we are a very happy builder whale. Finally, we have this command type command, and this is setting a default run command for our container, which we'll see in a second. But first, let's zoom out a bit and look at what this all looks like in the terminal. We see each of these steps being executed, which with a weird hash being given back. We'll look at that in a minute. And then finally, we have this successfully built tag and a tag with my app. Our Docker daemon has done its job, and we are left with this container marked in a way that we can access it. You can run this container by using this weird hash, even a small part of it, or you could run it by saying the tag that we gave it, my app. Now, running it like this without an extra command after the run argument will run this default npm start, in this case presumably starting a create React app. But you can give it a different command like bash, which gives you an interactive shell, and that will open up a shell in the container, which is a great way for debugging. You can do ls and look in all those directories that we saw in the container to really play around and see what the full capabilities of your container is. But it doesn't just end there. These weird hashes are also accessible, and each of these represents a snapshot in time of what the container looks like during that command, specifically right after it. But that's really cool because essentially you can go into the fourth dimension and you can go back in time, look through any of these different containers at the point when we built them. You can see each one of these represents a bit of that step, and this is called layering. It's especially useful if the build fails halfway and you only have a few hashes that were successful. You can look at the last successful hash and move around in it, see what files are in it, see what commands work in it and don't. You don't have to start from scratch again. It can be very powerful for debugging. We can't get into it now because we're out of time, but I hope you look at it later on in your development adventures. For now, I just want you to know that selecting the right amount of build context is really important. It can speed up time, but make sure it has all the files you need, because once you have it to the daemon, that's all he's got to work with. Next, files generated from the build processes or installs, things that are automatic, should happen in the container rather than your computer, which means we want them ignored. Next, errors that are found around files not being found. It's usually because it's copied to the wrong place, so just know that if it's talking about the daemon, did you bring the build context? If it's talking about the container, did you copy things to that container? And finally, take advantage of layering because it's super cool. I'll leave that point for you to try on your own. For now, I'll just say thank you so much for coming to this talk. Again, I'm Nick Palenchar. You can find me on Dev or Twitter to continue this conversation, or later on in Codeland. Thanks a lot.